how to make a normal probability plot using example 3.25 from section 3.2 of OpenIntro Statistics and the data file NBA heights. I already copied and pasted the data file to a spreadsheet. This is Google Sheet. Other spreadsheets can work just as well. Here's the steps. So first, step 1, arrange data from least to greatest, and then step 2, rank the data. So let's just do those 2 steps first. To sort data, you just select the top rows. You can do Control-Shift down arrow to quickly select everything if you have a really large data set. And then go to data and sort range. Other spreadsheets, the menus are a little different, so just figure it out. But they all can sort. Data has header row. Select height in inches. I want to sort by height in inches. Click sort, and then here it is. They've all been sorted. All 435 basketball players. So let's go back up to the top. So our shortest person is Nate Robinson. Oh, hold on here. Let's get last name back up there. He's 69 inches tall. Our tallest person, you can do Control down arrow. Our tallest person, Yao Ming, 90 inches tall. This, by the way, this is from, I think, the 2008-2009 basketball season, all the basketball players from that season. Okay, now make another column. Call it rank. So the shortest person is person number 1. The second shortest person is person number 2, and so on and so on. If you have a small data set, you can just type the numbers in yourself. If you have a large data set, a little shortcut is you click both the first two rows. Click the little dot in the corner. Double click actually, and then the spreadsheet notices the pattern and it just fills in the numbers for you. All right, there's the rank. Now we want to come up with the percentile. So next step, back to our steps here. Step 3, estimate the percentile with the formula I minus 0.5. I is the rank number divided by n. Or if n is less than 10, a different formula, but n is more than 10. So I'll use this formula right here. And then find the theoretical z-score using the inverse normal command of each percentile. All right, let's do those 2 steps here. So the idea here is, first of all, let's label this here. But we can call this percentile. The percentile just is the percentage of, in this case, basketball players who are shorter than a particular individual. So technically, I guess you could say this person here, Nate Robinson, is the 0th percentile because he is the shortest person. There's no one shorter than him. But with the inverse normal command, you can't have 0%. So we make a little adjustment here. We will take type equal sign, take the rank, put this in parentheses here, take the rank, which is in cell E2, minus 0.5 from it, and then divide that by the number of basketball players, which is 435. Divide by n. Okay, so we'll say that he's roughly the 0.1 percentile, shortest person. Now you can copy that formula down, just click the little dot, or excuse me, double click it. Oh, hold on, let's try that again here. I want to get all the rows. Okay, here it comes. All right, so these are roughly the percentiles of each player. So for example, Will Bynum, 72 inches tall, he's about like the 2nd percentile. All the way down, if you can do Control down arrow, all the way down to Yao Ming, which he would be the 99.88 percentile. All right, now the whole idea of a normal probability plot is to match up the theoretical z-scores with the actual data, which is the heights in this case. So how do you get the theoretical z-scores? Well, we have the percentages, so you use the normal inverse command. So you can do equal sign norm inverse INV. That's the command for it. The x would be the percentile right there. The mean is 0 because we're talking about z-scores. Standard deviation is 1 right there, closing parentheses. Okay, so here's what's going on. If we had a truly normal distribution, then theoretically speaking, Nate Robinson's z-score would be about negative 3.048. And then let's copy that down. Here it comes. Okay, so then the next person, Brevin Knight, his z-score would be theoretically negative 2.7. And the next person, Mike Wicks, his z-score would be negative 2.527. And all this is theoretically if we had a normal distribution. Now it's a big if. We don't know if we have a normal distribution. That's what we're trying to check. All right, all the way down to our last person here, Yao Ming. Theoretically, if we have a normal distribution, he would be about 3 standard deviations above the mean. His z-score would be about 3. So now, last step, we're almost done here. Step 5, make a scatter plot of the theoretical z-scores on the x-axis to the actual data on the y-axis. All right, so scatter plots actually is another chapter, but it's just a graph where the z-scores are the x-coordinates and the inches are the y-coordinates. So click the little insert chart icon or select it off the menu, insert in chart. And we want to select scatter plot. Oh, come on, taking the computer so long here. Try that again here. Here it comes. Okay, so Google took a guess on what my x and y coordinates would have been. It was a pretty good guess, but it wasn't quite right. If it doesn't guess scatter plot, just on chart types, select scatter plot, which is usually one of the first. Where there's scatter right there. If it doesn't guess that for you, data range. So actually, I want the z-scores on the x-axis. So that's in cells G1 through G436, and then the y-coordinates are the original data, which is the inches. That was in cell D1 to D436. Click OK. And there we have it. We have the theoretical z-scores here, the actual data here. So what this tells you is if the straighter the line, the more normal the distribution is. This one is pretty straight here, but not in this region. It kind of tips off to the side a little bit. So it's not quite a normal curve. But it's kind of a normal curve with the skew right there. All right, so that's how you make a normal probability plot.